Broken? What's wrong with it?
I don't know. I just sat down and
Oh. Oh yeah, it is broken. Yep. That little thing right here. Yeah, that's not good, huh? That's not good, huh?
Okay. Hi.
All right. So in the where is it by? It's a few days. So in the other class, they were asking me about the schedule for the rest of the semester. We have, counting today, we have 6 classes left. After today, there'll be 5. So today, we're going to do chapter 12. On Wednesday, we'll do chapter 13. There'll be a homework posted probably Wednesday morning for 12 and 13 together, okay? 12 is about some different functional groups, and then 13 is about carbohydrates. Then I want to do parts of 14 and 15, and then 16, and those 3 all kind of go together in 1 week, okay? What you'll see today is there are parts that we're going to skip, okay? So we can be judicious and effectively use the rest of our time left the semester. Some stuff that you guys need to know moving ahead and what this class is supposed to prepare you for. So we're trying to get you to know like what a carbohydrate is and what its structure looks like and that kind of stuff, okay? And then that last chapter we're going to do is about proteins and how proteins work. So that's where we're getting, okay? That's kind of how we want to deal with these last few chapters. So just know that it's going to seem like we're covering a lot of chapters, but we're not going to go into it in great detail. We're going to skip some parts, okay? Fair enough? Anybody have any questions about that?
Are the quizzes going to be lumped together?
Yeah, the quizzes will be lumped together too. So like there'll be 1 quiz for chapters 12 and 13.
Will it be twice as long?
No. No, because the quizzes are normally what, 25 questions or so? Price cookies. And it'll be time. It'll be about the same amount, right? Anything else? No? We're good? We're happy? We had a good weekend. Just one person, the rest of you had a terrible weekend? What'd you do that was so good, Allison?
Well, for one thing, I got a lot of rest, so that was pretty good.
That's good, yeah.
We finally got a car to replace the old one that completely just
That's
stopped
always
working.
good, right?
And we ordered some Chinese food, so.
Nothing wrong with that. That's a pretty good weekend. I didn't even do that much. I did a lot less than that. I didn't do anything. All right. How are you doing? Surviving. Day to day. Sometimes that's all you can do. Hang in there. Like I said, you let me know if you need it, okay?
Yeah, I'll try to take that in classes.
Okay. Understand. All right. So let's do chapter 12. And it won't even take us the whole class to do 12 because we're going to skip some parts, okay? So, chapter 12 begins. So far in our discussion of organic chemistry, we really only scratched the surface and we've talked about compounds that contain carbon and hydrogen and maybe some halogens, right? So like chlorine and bromine. So we've just barely started scratching the surface of the study of organic chemistry. These alkanes or alkenes, alkynes are a very small part of organic chemistry, but they are important, okay? I'm not saying they're not important. The part of organic chemistry that really starts to make sense or to show you how molecules behave and why they act the way they do in organic chemistry is this chapter where we start talking about what most people refer to as functional groups. And they call them functional groups because it determines the function of the molecule, okay? These groups are special things that are added on so that it's no longer an alkane. It's no longer a hydrocarbon, which is hydrogen and carbon. it now contains other stuff like oxygen or sulfur, okay? So we're gonna talk about these functional groups in chapter 12. The four that we're going to talk about in particular are alcohols, phenols, thiols, and ethers. Alcohols are any molecule that contain this OH functional group. That's called a hydroxyl group. It's not OH minus, it's not hydroxide, like when we talk about acids and bases. This is actually an oxygen that is covalently bonded to a hydrogen, and then also covalently bonded to a carbon. Okay? So it's attached covalently to something that was originally an alkane. Now it has an OH on it. It's an alcohol molecule. Okay? Phenols are a special type of alcohols which have a benzene ring, an aromatic compound, right? But they also have the OH on them. Okay? And we're going to go into more detail about each one of them, I promise. Thiols are kind of like alcohols, except instead of having oxygen, they have S's, which are sulfurs. Okay, we'll talk a little bit about thiols. We're also going to talk about some ethers. Ethers are molecules that have an oxygen between two carbons. Plus, we're going to talk about aldehydes and ketones too. So we're going to talk about a lot of different types or classes or functional groups today. So, we're not going to do a whole lot of naming in this. We will mention some names just so you get a little bit familiar, but we're not going to go into detail of naming like we did the alkanes. Note that we have methane and methanol. We have ethane and ethanol. The common name for ethanol is ethyl alcohol. Okay, I'm not going to use common names at all because I think they confuse the issue. So what do you notice the difference between methane and methanol? All it changes is the ending, right? So that's what you're going to see commonly on some of these molecules is the endings change for these molecules. We'll tell you what the functional group is. So methane becomes methanol, OL, means it's an alcohol. Thank you. Because I really don't care what he's doing.
Wow, man, no.
So, I'm not going to ask you to name this, but think about what it is. If you were to name this, what would be the first thing you do? What did we do before? Longest chain, right? What's the longest chain? 6. So it looks like hexane, but it's got an OH on it, so it's hexanol. Where is that OH? It's on the 2, so it's 2-hexanol, and it also has something else on it too, doesn't it? It's got a methyl group, so it's 5-methyl-2-hexanol. Okay? I'm not going to dwell on this, I'm not going to give you any homework naming these. Just know that that's kind of how they're named. Okay?
So, how do you know it's not the reverse?
Because the OH takes precedence over the methyl. There's rules for which one is more important than the other. Hydroxyl is more important than methyl.
So the hydroxyl.
So you're going to name number from that end as opposed to this end. Yeah.
Okay.
And I don't want y'all to get confused by all those rules. Okay? So we're not going to spend time naming. Okay? This would be 2-propanol, 4-methyl. So it's 4-methyl, 2-propanol. This is what a phenol looks like right here. Okay? Benzene ring with the hydroxyl. Oops. It also has bromine on it. So this is 3-bromo-phenol. Okay? What we do want to talk about is some reactions and stuff that these guys can undergo. So, fermentation. Fermentation is a bacterially mediated process where you take sugar, CH6H12O6, and you break it down and you actually make ethanol. So when you make your moonshine, you can just use cane sugar, or you can use apples or peaches or pears or raspberries or blueberries or anything that contains sugar. They normally use fruit because fruit is high in sugar, right? So they use fruits, and bacteria chew away at that sugar, and they break it down and make ethanol and CO2. You can use wheat. You use wheat or barley, you make what? Beer. If you use grapes, you make what? Wine. Same thing. It's the same process. It's a bacterially mediated thing, okay? Industrially, we don't make ethanol that way, right? They make ethanol, where do you find ethanol at? Anybody use any ethanol today? And I don't mean that you've been home drinking. In your gas. What do? They take the sugar out of corn and they do a process to extract alcohol out of it, ethanol. They do a reaction. They make ethene and then they add, what is the name for this reaction right here? What type of reaction is this? We did this last week. What type of reaction is that? What are you doing? And what do we call that? Hydrating. She's hydrating. Right? She's like, crap, what did I do? She's hydrating. We hydrate this alkene, don't we? That's how they industrially produce alcohols. Okay, remember last week we did a hydration reaction. We didn't call it an alcohol molecule because you didn't know what that was, but that's how they actually make alcohol. And where do you find ethanol? You find it in your gasoline. It's used as a solvent for different things like vanilla, perfumes. It's used in all kinds of stuff. It's used as a solvent in hand sanitizer. Okay, we'll show that in a minute. Here's an interesting looking alcohol. This is 1,2,3 propane Woo! Triol meaning it has 3 hydroxyl groups. OL means hydroxyls, right? Look, it has 1 on each carbon. That's why it's 1, 2, 3. It's very viscous. It's also known as glycerol. It's used as a solvent. It's also used in skin softeners. If you have hand lotion and you look at it and it says glycerol on it, that's the molecule that's in it. That's the solvent that they use in that lotion formula. Okay? Very common. Here's an alcohol molecule. Actually, this is a dual phenol molecule. This is BPA. Remember a couple years ago, there was a lot of people talking about don't drink out of plastic bottles and stuff because you get BPA from it. This is one of the polymers that's used in making polycarbonate, and it's a dual phenol. If you ignore the middle part right here, this part over here is a phenol, and this part over here is a phenol, and phenols are carcinogenic. So that's what carcinogenic means, causes cancer, right? So that's why people were saying don't drink out of plastic bottles and stuff because you can get BPA in your system and it's not good for you. Very small amounts leach from the bottles and you'd have to adjust quite a bit for it to be really bad for you. Here's some other common phenol molecules. There's isoeugenol, thymol, eugenol, and vanillin. Anybody ever smelled nutmeg, thyme, cloves, and vanilla? These are all common spices, right, that you use to cook with. I want you to look at the difference between nutmeg and cloves. So the first one and the third one. What's the difference between those two molecules?
One has a double bond, the other has a triple. Or no. The bonds are in different places.
Yeah, the double bond has just moved over one, right? Has anybody ever smelled nutmeg? Mm-hmm. Christmas, right? Anybody ever smell cloves? Mm-hmm. Do they smell the same?
No.
And that difference in the smell is all because of that position of that double bond. Okay? That's how good your nose is. That the receptors in your nose are very specific for that. Okay? Does that make sense? Mm-hmm. Okay. So, thiol molecules contain sulfur instead of oxygen. They look like a hydroxyl except they have SH instead of OH. Okay? Thiol molecules are responsible for some really nasty smells in the world, like skunks. Trans 2-butene 1-thiol. Yuck. Also, thiols are common in stinky cheeses. Who likes really, the stinkier the cheese, probably the more expensive it is. That's a good general rule, right? If you like good cheese. You like good cheese? It's expensive, really good cheese. And it generally has kind of a strong smell to it, right? And a strong taste. That's because of the sulfur that's in it. It's also responsible for the smell of garlic and onions and even oysters, okay? The sulfur is what your nose is very sensitive to, okay? Oh, we're not gonna worry about naming thiols, how's that?